my home office, and I'm just finishing up one of my winter projects here. I have the booklets ready to mail out, a few more to go. Spend quite a project here working on that. But I'd like to also take this time to show you one of the websites that's going to be very useful when we do quadratic equations and graphing quadratic equations. So with that, let's go to that website. Now, I'm on a typical browser, and in the search bar, just type the words Desmos.com and hit enter. And then it gives you this particular page. So what they're saying is, let's learn together, and we want to look at a graphing calculator. I've gone to a full screen so you can see everything. So let's go to number 1 over here and type in our first equation. So negative x squared and plus 4x plus 5. Now, there's the parabola that we've drawn, which is very nice, but we need to make it a little smaller so we can see it on our graph. Now, for this, we want to do a number of things. So the first thing we want to do is determine whether this equation, this quadratic equation, well, actually it's a quadratic expression at this point, is an example of a minimum or a maximum. Now, in our lesson, we had said, this is how I get my pens going. Again, the standard form of the quadratic expression is ax squared plus bx plus c. We said if our a term, which happens to be a -1 here, we don't write the 1, is negative, then the parabola is going to open downward, and the vertex, which is the highest point right there, this would be called a maximum. So anytime your a value is negative, the parabola will look like this. Now, we want to find, number 1, the vertex. Number 2, the axis of symmetry. Number 3, the zeros, which are the x-intercepts. Two words run together there. And then we also want to find the y-intercept. And there it's spelled out a little better. Okay, so how do we find the vertex? Well, we said the vertex, part of it, we use the vertex formula, which is a -b over 2a. So what is our a here? Let's just do that. Our a is a -1. Our b is a +4. And our c is a +5. So a -b, b being 4, would be a -4. And then 2 times a we say is -1. So 2 times a -1 is a -2. So when we simplify that, we get a +2. Now we're going to write our vertex as an ordered pair. So our x value of that vertex would be a 2. Now we still don't know the y value yet because there are 2 ordered pairs. Now notice, as we said in our lecture, our flipped classroom lecture, that the axis of symmetry is going to be whatever the x value in the vertex is. And we write that as x equals 2. Now, from a previous chapter, we know that this is a vertical line with the equation x equals 2. Now, where is that line? Well, that line is right here. And this is the axis of symmetry. Let me put some arrows on there. And as you can see, the equation of this line is x equals 2. But what we don't know is our y value. Now, as we look at this, it looks like it's projecting it over to the y-axis here, it's going to be a 9. Let's see if in fact it is a 9. Well, once we find our x value, if we put our x value into this equation, substituting the 2 where the x is, that should give us our y value. Because in a sense, it's this, in its function form, is y equals this. So we have a negative 2, it's our x value. That's going to be squared, plus 4 times our x value, plus 5. Again, substituting, we've done this before as well. So 2 squared is 4, and with the negative on the outside, this becomes a negative 4. And this is a 2 here, so this is 8 plus 5. 8 plus 5 is 13, minus 4 is 9. Ah, it does check out. We expected it to. So we now have our vertex. We have the axis of symmetry. We want to find our zeros, that is our x-intercepts. That'll be where the parabola crosses the x-axis here. Well, it crosses the x-axis when y is 0. So this is one of our x-intercepts, and this is the other. Now, writing these out, it looks like this one is negative 1, comma 0, and this one is 5, comma 0. Written in the form a, comma 0 is the formal way of describing the x-intercept. So, finding the zeros. Well, one of the things we said is if we equate this to 0, that is y is 0, if it's factorable, we could do it by factoring. Otherwise, we have to use the quadratic formula. And we also said that, the original equation is this. So we've got the graph of it. But an easier way to solve this, whether it's by factoring or the quadratic formula, is to get our a term to be positive. We're going to do that by multiplying everything by a negative 1, which will reverse all the signs. So this will then leave us with a positive x squared, a negative 4x, and a negative 5 equals 0. I've just taken my original equation and multiplied everything by a negative 1. Remember, this is going to be 0 here. Now, notice this factors nicely from an earlier lesson. Now, the signs, to get a negative in the middle, the 5 would have to be negative, and the 1 a positive. So equaling each of the factors to 0, this is x equals negative 1. This is x equals 5. Yes, it does match up. We have found the zeros. Now, for our last item is the y-intercept. Where does the parabola cross the y-axis? Well, it looks like it's crossing at 5. So the y-intercept would be 0, comma 5. Again, written in the y-intercept form, 0, comma b. And how do we find that? Using this formula. Well, if x is going to be 0 here, we just put a 0. And again, we're using the original equation for this. So this will be a negative 0 squared plus 4 times 0 plus 5 equals 0. So this is, well, this is y actually. This is 0, this is 0, so y equals 5. Yes, y equals 5. All right, we've done it for an equation where our a term is negative, and using this website to solve our equation and see a visual of it. All right, let's try one where a term will be positive and you're not able to factor it. I've written the new equation into our Desmos, and notice we're getting this type of parabola. So when a term here is positive, the parabola is going to open upward. And the vertex, which is right there, is going to be a minimum. But what is the vertex? Well, it's an ordered pair, and we're going to use the vertex formula to find it. So negative b over 2a. Now our b term is 3, so this will be a negative 3. And our a is a positive 1, so this is going to be over 2 times 1 is 2. So our x value of the vertex is going to be a negative 3/2. So a negative 3/2 is right there. So there's a -1, there's a -2, so 3/2 is right in the middle. So we'll put that in there, negative 3/2. But we still don't know what our y value is. Now, if we go over to the y-axis, it's not quite a -4. It's a little bit more. It's down a little bit. So we'll have to put this into this equation, and I'll work that out for you. Now, to do this in stages, so you don't get lost, there's my x value, a negative 3/2. And I'm substituting this x value into this equation over here. And when I square this, I get a positive 9/4. Here I get a negative 9/2, and I get a -2. Well, to get a value for this, I'm going to need to have a common denominator. And what is my common denominator? Well, if you all said 4, that is correct. So this is going to be a 9 minus. Now I have to make this an equivalent fraction with a denominator of 4. So I'm going to multiply it by 1 in the form of 2/2. So 2 times 2 is 4, and then -9 times 2 is a -18. And I have to multiply this to get a denominator of 4 by a 1 in the form of 4/4. So this becomes 4, and this is now -8. So if I take away this and 1 from here, that gets rid of this 9. So this is going to become a -17/4. Now, if I change that to a mixed number, this is going to be a -4 1/4. Now notice, this is where -4 is, right here. And that's just a little further down. And we now have its exact value. So the vertex here is going to be a negative, and I'm going to leave it in its fraction form, 17/4, which we know is right there. So what is our axis of symmetry? Well, it's going to be our x value. So this will be x equals a -3/4. And let me draw that in. So I'll use blue for this time here. Get a little line there. And it's right in the middle. So there's my axis of symmetry. Now, keep in mind, the axis of symmetry just divides the parabola into two sides that are like mirror images of each other. Now, we need to find the zeros. Let me use black for this. So our equation is x squared plus 3x minus 2. Now, this is not going to factor. So I'm going to have to use the quadratic formula for this. X equals a -b plus or minus the square root of b squared minus 4ac all over 2a. So as to keep this a little short, I'll do the work and then get back to you. So I said we'd have to use the quadratic formula to find these zeros. So I substituted my b is 3, so -3, plus or minus -3 squared is, or 3 squared is 9, minus 4, a is 1, c is -2. Now as I do these, a negative times a negative will make this a positive 8, and 9 give me the square root of 17. So there is my x values here, and I write it up separately. There's one value, which is this x-intercept here, and there is that x-intercept there. Now, what is the y-intercept? Well, that's actually showing up very nicely here. It looks like it's going to be a 0, -2. And again, if we go into our original equation, then x is a 0, this is a 0, this is a 0, so y is -2. It checks out very nicely. Okay, so using this site to help visualize what these quadratic equations are like, where one is a minimum, one is a maximum, depending on your a value in the quadratic expression, and then going through this protocol. All right, about 20 minutes here.